Fourth grade lesson 6.6 is comparing fraction using benchmarks. So benchmarks are like a point of the fraction that your brain really knows. So using that piece of information, kind of that flagged piece of information, to help you recognize other fractions is what we're going to learn in this lesson. And in this lesson, I'm hoping I can help your brains recognize something about fractions a couple of things that I've recognized when I taught math at those upper grades. Some kids didn't have that recognition, and that made understanding fractions and calculating with them really difficult. So I'm hoping I can clear that up for you now so that it makes things easier when you're working with fractions later. Our essential question is, how can you use benchmarks to compare fractions? Let's first unlock the problem. David made a popcorn snack. He mixed 5/8 gallon of popcorn with 1/2 gallon of dried apple rings. Did he use more dried apple rings or more popcorn? Did he use more? Did he use less? What's their comparison? So we're simply comparing those numbers, which one's greater and which one's less. And of course, when we have whole numbers, you have become experts at what's greater and what's less. That didn't come automatic. You had to learn it, right? Way back. Well, I'm hoping I can help you make fraction recognition of greater or less automatic also. That's my goal. So we want to use the comparison of 5/8 and 1/2. So compare 5/8 and 1/2. And if you have access to those little fraction blocks and you think that will help you, grab some. If you're in my classroom right now, you have access to those. So just ask me for them if you feel like that would help you. They draw them out, but if you'd like to have the blocks to work them through, I have those for you. Use fraction strips to compare 5/8 and 1/2 and record on the model below. So you can put two 1/2s together, one out of 2 here and the other one out of 2 here. And then underneath it, you can put 8 of these 1/8 strips. And by now, I'm hoping you're recognizing if you have all of those 8 out of 8, that's one whole compared to the one whole here. And so now we would just need to shade in 5/8 and 1/2 and compare them. So let's shade those in. Let's do the 1/2. 1/2 looks like that. And 5/8, there's 1/8, 2/8, 3/8, 4/8, and 5/8. So which one is more? Which one has more amount? It's the 5/8 that has more than the 1/2, correct? So we're going to make the alligator after that. Alligator always goes for the larger amount. So David used more gallons of popcorn. So that's one way you can figure out which is bigger and which is smaller. This next question is going to address one of the two things I mentioned that I really want to help your brain catch on to in this grade level. Before we do that, the other thing I want to help your brain catch on to is this. And I don't think that the lesson is going to cover this because it is something that was covered before, probably last year, and the review is going to be helpful. One thing I ran into in those older grades is when I asked students to find on a number line, which you'll be doing in the next couple of years, where a fraction fell on a number line, they couldn't do it. They were very confused with how to do it. So I want to just reiterate to you, if we have a normal number line like you've seen for years now, 0, 1, 2, 3, 4, 5, 6, 7, 8, and we're talking about these fractions with no number in front of them. Anytime you have this fraction, this proper fraction where the little number's on top and the big number's on bottom, and no number in front of them, we haven't even made it to one whole yet. That's what this is. This is 0. I have none. And this is, I have one whole candy bar. This is 0 and one whole candy bar. It's all of the stuff in between 0 and 1 right here. So we've zoomed in when we're talking about fractions, proper fractions with no number in front of them. We are zooming in to this section here, where 0 out of whatever you're breaking it into, let me get a number here, 0 out of whatever amount of parts you're breaking it into, we'll call it X for now, I don't know what you're going to break it into, is 0. And the whole amount of all of those that you broke it into is one whole. And if you go over that, then it's something else. So I just want to try and clarify that a little bit with you guys so that you can see that we're only dealing with this section right here when we're talking about the fractions. Okay? And so the benchmark they're about to talk to us about with this 1/2 is helping us find that midway point right here, 1/2, that our brains are fairly familiar with. We're fairly familiar with 1/2. If I have a candy bar and I want to share it with you, and fairly, each of us gets 1/2. That's an amount our brains recognize pretty well. So it is not a whole candy bar, but it's not none of the candy bar. It's exactly half of the candy bar. So that's what it looks like on the number line. This is what it looks like as a candy bar. Let's talk about this now. And so I was just trying to make sure your brains understood fractions are not full 1, but they're not 0 either. They're just in between. So they want us to write 5 fractions equivalent to 1/2, those equivalent fractions that we've already learned, so we should be able to do that just fine. We'll do it together. And then once we've done that, well, let's do that first and then we'll go on. Let's do 5 fractions equivalent to 1/2. So we will do 1/2, of course. We'll start with 1/2. And remember, to keep a fraction equivalent, whatever we do to the numerator, we must also do to the denominator. So if we multiply the numerator by 2, we must multiply the denominator by 2. If we multiply the numerator by 10, we must multiply the denominator by 10. That will keep the amount that you've eaten, let's say, the same, just the way we cut it up different. Okay? So let's go ahead and just go simple. Let's multiply by 2 both numerator and denominator, and that's going to give us 2/4. And so that our brains can see it, let's do 1/2 and oops, pretend that's the same size. Let me fix that. It's all assuming these are the same size pies, right? Pretend those are same size pies. Sorry. There's 1/2. That's hard to see. There's 1/2. And here's 2 out of 4. Same amount, just cut differently, equivalent fractions, right? All right, they wanted 5 fractions that are equivalent to 1/2. Okay, how about, let's multiply by 3. 1 times 3 is 3. And 2 times 3 is 6. And let me just let your brains see that. We've got divided into 6 equal pieces, and you get to eat 3 of them. Same amount, cut differently, equivalent fractions. Okay, let's get a 4th equivalent fraction. Let's multiply each by 4, let's say. 1 times 4 is 4. And 2 times 4 is 8. Let's have a look. I'll do it over here. And I'm cutting this into 8 equal pieces. And I'm shading in 4 out of those 8. 1, 2, 3, 4. Same amount, cut differently, equivalent fraction. And finally, let's multiply both by 5. 1 times 5 is 5. And 2 times 5 is 10. And for your brain to see it, let's draw it. Still working on getting our brains to recognize equivalent fractions. There's 5 on that side. Pretend those are equal size. 5 on that side. And we're coloring in. So there's a total of 10, and we're coloring 5. 1, 2, 3, 4, 5. Same amount, cut differently, equivalent fractions. So all of these are representing the same amount. They're just cut up differently. So they look like different fractions, even though they're not. And we've learned that if you see something like this, reduce it down to its lowest form. Uncut it to its easiest amount for your brain to recognize, whatever that is. So here we have equivalent fractions that are the same as 1/2, same amount. Write the relationship between the numerator and the denominator of fractions equivalent to 1/2. So now this is real important. I want you to recognize this. 1 and 2, let's look at the relationship between them. It's exactly half of this, right? 2 and 4. Well, 2 times 2 gives me 4, right? So I know I can reduce that down to 1/2. I know this number is exactly half of that number, and that brings me back to half. 3 and 6. Wow, this number is exactly half of that number. So we're at half again. 4 out of 8. Wow, 4 is exactly half of 8. 5 and 10. 5 is exactly half of 10. So what you hopefully are going to see here is anytime your numerator is exactly half of your denominator, it will reduce down to 1/2. It is reflecting 1/2. If your numerator is exactly half of your denominator, no matter what your denominator is, let's go big now. Let's go ahead and bring up to, let's say, 100. Well, what's half of 100? Right, 50 is half of 100. This is half of my denominator. That means that this is a half. On the number line, it's right in the middle, between 0 and 1. So what we want to make sure our brains understand is if I'm taking a look at this and my numerator is exactly at the midpoint of my denominator, then I'm talking about halfway between 0 and 1. Half. Okay? So let's get our brains to wrap around that. Okay, now this one was a really important piece of information I want you to kind of connect to. So if you need me to explain that better to you, if I didn't explain this well here, stop and have me explain that better to you. Come find me in class if you're in class, or find me tomorrow if you're doing this at home. How many 8s are equivalent to 1/2? Well, 8 is our denominator here. How many 8s were equivalent to 1/2? 4 8s were. The numerator needs to be exactly half the denominator. How can you compare 5 8s and 1/2 without using a model? Okay, so this is where you start using that benchmark. If we recognize that any time my numerator is half of my denominator, then I know that's the halfway mark. So if I'm comparing it to a benchmark of 1/2, is it bigger than 1/2 or smaller than 1/2? I just need to think about what the midpoint is. So if I'm looking at 5 8s, oh, I need a pen, 5 8s on our initial question, and I didn't have the tiles, and now I know this, I could say, well, I know that 4 8s, 4 8s is exactly 1/2. But this isn't 4 8s, this is 5 8s. That's a little bit more than 4 8s, 5 8s. So is this one more than 1/2 or less than 1/2? Well, if 4 8s was 1/2, then 5 8s is more than 1/2, just by a little bit, right? Somewhere in this area right around here-ish, right? It's a little more than half. I can compare 5 8s to 1/2 if I understand this information of what makes a fraction half. If your numerator is exactly 1/2 of your denominator, that's the halfway point. So if your numerator is more than the halfway point, it's more than 1/2. If it's less than the halfway point, it's less than 1/2. And that's this lesson entirely. Let's look a little more at this lesson. All right. So they talk about a benchmark here. I've kind of mentioned it, but let's let them mention it in case I didn't mention it well. A benchmark is a known size or amount that helps you understand a different size or amount. You can use 1/2 as a benchmark to help you compare fractions, especially since you know that all of 1/2's equivalent fractions is always going to have the numerator as exactly half of the denominator. And I'm going to put those up here just for you to have. 1/2, or 2/4, where 2 is exactly half of 4, or 3/6, where 3 is exactly half of 6, or 4 8s, where 4 is exactly half of 8, or 5 tenths, 5 is exactly half of 10. Those are all equivalent to 1/2. The numerator is exactly half of what the denominator is. So get that kind of stuck in your head. A family hiked the same mountain trail. Evie and her father hiked 5/12 of the trail before they stopped for lunch. Jill and her mother hiked 9/10 of the trail before they stopped for lunch. Who hiked farther before lunch? So there's a lot of ways we could do this. We could do all of the calculations to get common denominators and see which is more and which is less once we have a common denominator. But there's an easier way, and that's what this lesson is showing you. There's sometimes an easier way, I should say, because I can simply use my benchmark of 1/2 to help me. And I'm going to draw the number line again because I really want your brains. Oh, and they have the number line there. But notice here, you guys, that they just have the number line 0 to 1. Because again, pen, 0, 1, 2, 3, 4, 5, 6, 7, 8. Again, I just want your brains to make this connection that fractions are zooming in on this number line that you're very, very familiar with, all this whole number line. It is zooming in to just this part. You are not going above 1 on the number line. It's all the numbers that are in between. All the in-betweener numbers are fractions. Fractions are in-betweeners. They live in between the whole number, between 0 and 1 in this case, okay? So let's take our benchmark of 1/2 right in the middle, and let's talk about our benchmark. The first fraction I'm going to look at is 5/12, and I'm going to use this denominator 12 and identify my benchmark for that one, denominator of 12. What is half of 12? Half of 12 is 6, right? So if the denominator is 12, 6/12 is the halfway mark, right? Okay, 6/12. How does 5/12 compare to 6/12? 5, since our denominator is the same, we can look at those numerators. 5 is a little bit smaller than 6, isn't it? I don't know, where exactly on the number line it's going to go, but it's going to be a little less than 1/2. Not by a lot, but a little less than 1/2 somewhere. 5/12, okay? Let's take a look at the other one we need to compare, 9/10. Okay, that is with a denominator of 10. I'll use a different color here. Let's go with this. Okay, tenths. Well, what is my benchmark? The 1/2 mark. What is half of 10? 5 is half of 10. Okay, so this is my benchmark of 1/2, 5/10. So I'm looking at 9/10. Denominator's the same, so I can just compare my numerator. 9 is more than 5, so 9/10 is going to be on the upper side of 1/2. It's more than 1/2, somewhere living in this area up here. In fact, it's almost 10/10. Remember, 10/10, it's another benchmark really for us. 10/10 would be the whole thing, all of the 10 pieces that we cut up. So that would be 1. So it's almost the whole thing. Okay, so if they're just asking me to compare these two numbers to each other, after this lesson and with practice, you'll start noticing, well, that's less than half and that's more than half, so this guy's obviously bigger. Okay, so you're going to notice that 9/10 is bigger than 5/12. You won't notice that right away. Don't expect yourself to notice that right away, but with practice of using benchmarks and understanding your fractions, you will eventually be real quick at that. Okay, and that's going to be helpful to you. Let's go ahead and walk through these steps with them, though. So we have with the visual. I wanted you to walk through the steps without the visuals yet, because I wanted you to see where they're going with it. Some of you will connect to that right away, and some of you are going to need these visuals, and whatever you need, that's what you need. Be patient with your brain. All right, compare 5/12 to 1/2. So that's what we were doing here, and we found the midpoint, 12. Half of 12 is 6. That's the halfway point. And compared to 12, 5/12 is right here. Let's highlight those colors in. 1, 2, 3, 4, 5/12 is right there. And the halfway mark is just a little more. So 5/12 is smaller than 1/2. Alligator goes to the bigger number. Half is bigger. 5/12 is smaller than 1/2. Let's compare 9/10 to 1/2, and that's what I had done down here. I said, well, half of 10 is 5. That's my halfway mark. Okay, and they're doing it visually here now. Here is 0. Here is 1. Here is 1/2. 5/10 is half. That's what you had identified here. Let's shade that in. We're looking actually at 9/10, so we're going to shade in 9/10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember how I said over here it's gonna be almost the same, the whole thing, right? It was, right? It's almost the whole thing. If you got 9/10 of the candy bar and I only got 1/10 of the candy bar, you got most of it. All right, and it went well beyond the 1/2 mark, right? So 9/10 is much bigger than 1/2. Since 5/12 is smaller than 1/2, smaller or less, let's use less, it's shorter to write, it'll fit on the line, and 9/10 is more than 1/2, then you know that 5/12 is smaller than 9/10. So because they fell on different sides of your benchmark of 1/2, that made it easy to compare. So who hiked further? It was whoever did 9/10. Jill and her mother hiked 9/10. So Jill. And mom, but just put Jill. Okay, and number 4 takes us back to kind of what I was showing you before. I went in a different order. I hope I didn't confuse you. I was hoping to make the connections, so I'm sorry if I confused you by going in a different order. I felt like that would help a lot of you make some connections though. Explain how you can tell that 5/12 is less than 1/2 without using a model. Well, if my denominator is 12 and 1/2 of 12 is 6, then I know that's the equivalent fraction to 1/2, right? So 6/12 is half, and 5/12 is smaller than 6/12. Therefore, 5/12 is smaller than half. 6/12 is half, 5/12 is smaller than that, 6/12 is half, 5/12 is smaller than that. There's the visual, but there's the how you reason it out. Okay. Explain how you can tell 7/10 is greater than 1/2 without using a model. This is a different fraction than before, 7/10. Let's start with our benchmark of half, the equivalent fraction with a denominator of 10. Start with the benchmark. Okay. 10 is my denominator. What is half of 10? 5. So 5/10 is half. That's the equivalent fraction for half if it's cut into 10 equal pieces. And 7/10, well, 7 out of 10 is bigger. 7 out of the 10 pieces is bigger than 5 out of the 10 pieces. So 7/10 is greater than that, is more. So therefore, 7/10 is larger than half. 5/10. 5/10 is half, right? That's what we're saying here. 5/10 is half. So if half is 5/10 with the same denominator, 7 is more than 5, so 7/10 is larger than 1/2. And of course, this is going to take some practice and some patience with your brain, but you will get it. All right, they want us to compare 2/5 and 1/8. 2/5 compared to 1/8. All right, I'm going to just use my benchmarks, and they're doing it step by step. Okay, let's let them take us step by step. If I have, we're going to use our benchmark of 1/2. That's the easiest one for our brains to recognize. Let's use it. We have 0, we have 1/2, and we have 1 full. 2/5. Well, half of 5 is like 2 and a little bit more. 2 and a half, okay? So it's 2 and a little bit more. That's a trickier one. Just know you can kind of know there's an in-between there, especially now that we're learning to deal with in-between numbers. So 2 and a little bit more would be half of 5. That's kind of tricky, I know, but 5. If you had $5, use money to help you. You guys understand money really well. If you had $5 and you wanted to share it equally with me, you recognize, oh, each of us is getting $2, and then, maybe we're tearing the dollar in half. That would be useless. We'll get quarters, right? We'll split it. So we get $2.50, right? Use money to help you understand that in-between step, because that's what coins are, is in-between whole numbers, in-between dollars. So we know it's a little more than 2. 2 with a little bit more. I'll say 2-ish, okay? Well, 2/5 is only the $2, and we're not accounting for the little bit more-ish, the coins we're talking about. So we're a little less than 1/2 when we're talking about 2/5. Almost there, but not quite. And 1/8, we have a denominator of 8. What's half of 8? 4. Here it is showing. Okay, that's our benchmark. But here we're talking about 1/8, not 4/8. Oh my goodness, it's hardly any. So we know that this is much less than 1/8. Than 1/2. This is much less. This is less than half, but it's almost half, right? And this is much less. So when you can see that it is much less, when you feel like, wow, this is way off. Remember I said, well, 2/5, it's almost there. This was 2 and a little more, so we're super close. And we have 4/8, and wow, 1/8 isn't even close really to 4 when you compare it to how close this was. Then you are going to start recognizing those differences. You may not yet, and that's okay, but you're going to start recognizing those differences just visually without having to draw things out. When you draw it out, it makes it easy. Draw it out as long as you need to. But eventually, your brain is going to make the connections and won't need to anymore. Just be patient with it. So 2/5, look at how much closer it was to 1/2 than that, is greater than 1/8. Alligator gets the larger number. Okay, let's practice a few, and I will draw these pictures out too for those of you who need it. If you aren't needed the pictures after we've solved it, if it makes perfect sense, then forward through them. But here is between 0 and 1 on the number line, and of course it goes on 2, 3, 4, 5, blah, 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 but I'm only focused on these because these are proper fractions here, meaning small number above the big number. So it's always going to be between 0 and 1. We're talking about the in-betweens between a 0 and a full, between a $0 and a $1 bill. The in-betweens, the coins. Okay. Well, 1/2 is our benchmark. We know exactly where that's at. 4, 6 in comparison, let's use a denominator of 6. What is half of 6? 3 is half of 6. And 4 is a little bit more than 3. So this number is a little more than half. Okay, and if we need to see it drawn out, here it is. I would be splitting this into 6 equal pieces with 3 on this side and 3 on that side. There's 6 equal pieces. Sorry about my rectangle being all wonky there. Anyways, you get the idea. And if I shade in 4 of them, 1, 2, 3, 4, it goes past 1/2. Okay, there's the visual. All right. I can't erase it now, so it's stuck there for good. Maybe I can shrink it. No, I can't. I shrink the whole thing. Oh well. Anyways, there it is. Let's look at 3/10 compared to 1/2. Okay, 1/2 is our benchmark anyway. Let's look at half as a denominator of 10. What is half of 10? 5 is half of 10. And when you compare 5 to 3, 3 is smaller than 5. So 3/10 is smaller than 1/2. And here it is visually for those of us who just need to see it for a little while, and that's okay. The halfway mark is 5. 1, 2, 3, 4. So this is 1, 2, 3, 4, 5. I put 4 hash marks because this ends up being one of those hash marks. So 1, 2, 3, 4, 5 segments. Same thing over here. I'll put in some 4 hash marks, 2, 3, 4, because this last one becomes that 5th, and that's 1, 2, 3, 4, 5 segments. 5 segments plus 5 segments equals the denominator of 10 segments. And if I shade in 3 of them, 1, 2, 3, and we can now see, yeah, that is less than 5/10, than half. Okay, let's look at a few more examples. I split them up, so maybe this won't be... I worried that maybe on the last one, having them right on top of the other, the drawings, was confusing, so I'm going to split these up and see if that will help if I confused anybody. 11/12 is what we're comparing to 4/8. Use our benchmark of 1/2 to see if that helps us. And some of you might be recognizing 11 out of 12. If 12 out of 12, that's another benchmark, honestly. If 12 out of 12 is the whole thing, 11 out of 12 is pretty darn close to that, right? Okay. 12 out of, if 12 is my denominator for half, half of 12 is 6. And 11 is much better than 6. So we know 11/12 is somewhere in this upper part of between 0 and 1, and it's really close to the top end of it. Let's look at 4/8 now. 8 is our denominator. 8. And what is half of 8? 4 is. Oh, so 4/8 is in fact half. So of these two, 11/12, which is living somewhere up here, and 4/8, which is exactly half, which one's larger? This one, right? It's closer to 1. You get more candy that way. So alligator goes to the larger number. He wants more candy. All right, let's look at this next one. 5/8 is being compared to 2/5. Let's use that half mark. This 5 one is harder. If these denominators are odd, it's hard to find the exact in-between number. Just think of what you know about money again. So with practice, though, they become easy. Your brain adapts to it, no problem. So don't worry. If it's a little shady now, though, that's okay. Be patient. Let's do the half equivalent with a denominator 8. 8, half of 8 is 4. And I'm seeing that 5 is more than 4. So this number is a little bit more than half. Right around here-ish, somewhere in there. Maybe in a darker color would be better. Somewhere in here-ish. Okay? I don't have to be exact. That's not what they're asking me to do. Then let's look at 2/5. Well, I don't want to write that there, actually. Take it back. Okay. I'm looking at 2/5. So my denominator is 5. And my numerator is, well, no, if I'm looking at my half benchmark, if my denominator is 5, what would half of 5 be? And that's odd, so it's harder to picture, or it's harder to find right away. That's okay. Think of $5. If you have $5 and you're sharing equally with me, each of us is going to get $2.50, right? A little more. So we're just going to put 2, because we haven't talked about decimals yet. We will later. So I'm just going to put 2 and a little more, plus to mean a little more. Not 3, but 2 and a little bit more. Well, this number is 2/5, not 2 and a little more, just 2/5. So it's a little bit less, living somewhere in this area-ish. Somewhere in there. Ish, right? In any event, it's smaller than this amount. 2/5 is smaller than the 5/8 amount. So 5/8 is what the alligator wants. Okay, at this point, if you get it and you feel like you're ready to ditch me and go show me that you understand it on Think Central, you go right ahead. You have completed all of the share and show. For those of you who are feeling like I could use just a little more practice with you, Miss Sanchez, can you just walk me through a few more? I'm going to do that with you here. Okay, let's look at number 6. I'm comparing 8/10 to 3/8. Okay, let's start with denominator 10. Benchmark for half with the denominator 10. What is half of 10? 5 is. That's the equivalent fraction for half. And now that I have the half mark with a 10 denominator, I can compare the 5 to the 8. 5 is smaller than 8. So 8, well, I should say it this way instead so I don't confuse us. 8 is larger than 5. So 8 is going to be somewhere up in here-ish. I don't know, somewhere in here. It's in that upper half, right? Okay. Now let's look at our other fraction, 3/8, denominator of 8. What is half of 8? 4. So there's our equivalent fraction with the 8 denominator. 3 is smaller than 4 by a little bit. So it's somewhere in here-ish, okay? But when you compare the two, which one is larger? Which one does the alligator want? He wants this one. This one was the 8/10. So he goes to that one. If that's all you needed as the last set of practice and you're like, oh, totally got this now, you're free to go and go on Think Central. If you want one more with me, here we go again. 1/3 compared to 7/12. Okay, this one's a little trickier because of that odd denominator, but don't worry, you've got this. Let's take a look at that one. I need a denominator of 3, and I need half of 3. Think of dollars, okay? $3. If you're sharing $3 with me, I get one, you get one, and then we have to get quarters, right, for the third dollar to share. So we're going to just say that denominator is 1 and a little bit more, 50 cents more to be exact, but we're just going to put 1 plus 1 and a little bit more. We'll give the decimal to that when we get to talking about decimals later. For now, I just want you to recognize it's 1 and some change, okay? Well, 1/3 in comparison to that, it's 1. Not 1 and a little more, it's just 1. So it's a little less than half, somewhere in here. Okay, then for this one, I have a denominator of 12. What is half of 12? 6 is half of 12. How does 6 compare to 7 twelfths? 6 twelfths compared to 7 twelfths? 7's a little bigger than 6. So it's right in here-ish. We don't have to be exact about where. We just need to know where it compares to the 1/2. And once I compare that, oh look, this is bigger than that. So alligator wants that. Okay. All right, I think I'm gonna go ahead and do this one without the number line first, just so you could see how I'm gonna do this. It's how you would do it so you don't have to keep drawing number lines, because eventually you're not drawing number lines anymore. All right, I'm just gonna start now using the fraction, the half benchmark fraction. 6 is my denominator, and half of 6 is 3, and so this is less than half. Okay, over here, 8 is my denominator, and 4 is half of 8, that's half, and 7 is more than 4. So this one's more than half, and this one's less than half, so this one is bigger. And in case your brain isn't ready to just do it that way and needs to see it, that's no problem. If that's what your brain needs, give your brain what it needs. So we're going to do the 6 with the denominator 6. We want half of 6, that's 3. And 2 6 is a little smaller than that, so it lives somewhere in here. And then we need an 8 denominator. Half of 8 is 4. And 7 is more than 4, so it lives somewhere up over here. And now I can see on the number line, if my brain needed to see that this one is more than half and this one's less than half, so obviously this one is more than that one. And that's why we went that way. I hope I've explained it well enough to help you make sense of it. I'm happy to sit with you and practice a few more of those out of your book in class if you're needing it. It does take practice, but you will get it. You don't have it yet, maybe. If you don't have it yet, that's okay. You don't have it yet. You will. You'll get it. It'll take practice, and I'll practice with you gladly.